So what is the basic idea behind solving trigonometric equations? But let's start with the unit circle and just make sure you understand some basic facts. Like for instance, when I say sine of pi is equal to 0 and cosine of pi over 3 is a half and tangent of pi over 4 is 1 and tangent of pi over 6 is root 3 over 3. Do you know where I'm getting these from, right? So the unit circle is extremely important, and it gives you calculations of angles for these values. Labeling it in terms of pi is the first step. And then from there, you can very easily determine what these are, but you have to know those basic facts. The first one I made very simple in case, you have just a little bit of understanding. You can understand that this is how I got that, right? Cosine, sine, that's the value for sine. Pi over 3 is the one that is up here. So cosine for that one would be 1/2 root 3 over 3. Remember my little trick that this is pi over 2, which is like a half, so that's where the half comes first. Tangent of pi over 4 is the one that's here. And remember that those are root 2 over 2 and root 2 over 2 for sine and cosine. So when you divide them, you just get 1. And then tangent of pi over 6 is the one down here. And remember my hint to that one was when cosine is root 3 over 2 and tangent is root 3 over 3. So what is solving equations? It's just doing this in reverse. So, but in reverse, if I wanted to solve this, I would inverse sine this, and then I would give the angle that you just saw a second ago. So theta would be equal to pi. But there's more than one answer. So here we input one thing and we output one thing. But is there another place that sine is equal to 0? Of course, right here, sine is also equal to 0, right? I'm sorry, this was a negative, doesn't matter, but this one is now correct. So you can see that sine is equal to pi at both 0 and pi, right? So it's 0 and pi and 2 pi. So you've got to be careful about how you do this. Like for instance, cosine, we already said was a half up here. But if you use all students take calculus to understand where it's also positive 1/2, all students take calculus. When you inverse the cosine on both sides, you end up getting 2 answers, right? The initial one that we had, that was the pi over 6 answer, that was right here. Sorry, the pi over 3 answer, that was right here. But then also here, right? Because all students take calculus, it would also be positive there. And the way you remember this is, remember, this is really 2 pi, which in terms of 3 is 6 pi over 3. So if you go 1 less, that would be 5 pi over 3. Now for tangent, same situation, right? All students take calculus. The first one we found was right here at pi over 4, right? And then the other one would be just connected down here. And again, this is pi, so this would be 4 over 4, so that would be 5 pi over 4. Of course, you have the inverse tangent as well. Now, the last thing you're going to do here is remember that tangent is just a line. So in many ways, tangent is easier. So if we found this first one here to be at, at pi over 6, then the other one would be here. If this is 6 over 6, this would be 7 pi over 6. So not too hard. I do know that some students, they just struggle with getting the unit circle. So if you don't know the unit circle, clearly that's going to cause you some trouble. You have to understand the unit circle to continue in math and trigonometry. If you don't understand the unit circle, you're in trouble. So once you do understand the unit circle, this is actually a very, very easy subject. It just goes in a reverse order of Gelndas. You add or subtract around the trigonometric function. You multiply or divide to get that trigonometric function by itself. Sometimes you have an exponent, usually it's a square, so you put plus or minus on something. And then you get rid of the grouping symbol, the sine, cosine, or tangent, by using inverse sine, inverse tangent, or inverse cosine, like I did right here. And those answers come from the unit circle. Okay, please make sure that all trigonometric answers are represented, including infinite answers, which include coterminal, and then we'll go over that in just a minute. All right, so let's take a look at how to solve. It is pretty straightforward if you understand that we're just reversing the order of operations. Please notice here that it says to do it on a certain interval, meaning this one's answers from 0 to 2 pi, and this one's in degrees. So sometimes they want degree answers. So you just look at this problem and you ask yourself, is there something to add or subtract? No, right? So just reversing the order of operations. That's all we're doing, right? We're just reversing this. And if I go from the bottom to the top, I don't have anything to add or subtract, but I do have something to divide. So I divide by 2. And then that gives me sine of x is equal to root 3 over 2. And in effect, what this is saying is give me all the values that will give me this angle. I mean, this measurement, all the angles will give me this angle. Of course, there is this step to do that with, right, that we have to do. And so x is equal to the inverse sine of root 3 over 2. And the first one is very simple, right? So draw a unit circle, and it's the one that's right here, right? That's a half, and that's root 3 over 2, and this is cosine and this is sine. Remember, this is pi over 2. That's how I remember the cosine's a half there. So the first answer should be very easy, right? Just don't give me, give me this angle, right? That angle is pi over 3. So now we need the all students take calculus, right? And so all students take calculus tells me that sine would also be positive right here, and that one is 2 pi over 3. And that's it. It's pretty easy to do. You just have to know the unit circle. So here, do I have anything to add or subtract? Yes, I have this to subtract. Okay, and so then we have 4 cosine x equals -2. And then you divide by 4. And then you have cosine of x is equal to -1/2. So it's very similar to this one, but we want to know where it's negative, right? And so let's just stick with this value right here. If we would have labeled it, it would have been -1/2 root 3 over 2. And this is cosine and this is sine. So the first value, when you inverse cosine this, the first value that is true is the same one that was true a second ago. And that's one thing that does make some students confused, but you got to understand the unit circle is able to find both cosine and sine every time you write it. So the first answer makes perfect sense. It is at 2 pi over 3, because that is where cosine is -1/2. And sine was root 3 over 2, but again, we're just doing a different problem. It does have the same answer. So the other answer is where cosine would also be negative, which would be here. And so again, if this is 3 over 3 pi, this one would be 1 passive or 4 pi over 3. Again, knowing the unit circle is essential. So in this one, I'm really just trying to focus on the idea that you don't have any addition or subtraction. All you have is an exponent, and you take the square root. But students, for some reason, always forget to put the plus or minus on square roots. And in the world of trig, that is going to be a nightmare. By the way, the square root of 1 is 1. So then when I inverse tangent both sides, we get the fact that we want to find all the angles in which tangent will produce a side of the hypotenuse or a slope of the hypotenuse of plus or minus 1. Well, clearly the first one is at 45 degrees, and you might say, why am I doing degrees? Well, because it says to in the problem, do degrees right here. And then the plus or minus means all of them, right? So we have this one here at 45, but then there's also one here that would be -1, and this would be +1, and this would be -1. So what's all of them? And again, if you don't know your unit circle, it's just really important to understand it. I would advise drawing it once a day while you're in trig class to remember it. It's actually what I do before class sometimes when I'm feeling kind of like mushy in the brain. So if this is 180 and I go back 45 degrees, right, because all these reference angles are 45, then the one before this one would be 135. And then the one after it down here would be 225. And the reference this over here at 360, this one would be 315. Okay, so that gets us into the next part of what's going on, is that if we were to use coterminal angles, and for instance, if we were to look at this one, and we started at pi over 3, and we just kept going around in a circle, you would get an infinite amount of answers by simply adding 2 pi to this, as well as the one over here. So some students get really confused when people give answers in infinite sets. But if I take pi over 3 and I just add every integer pi value, it's kind of like doing those tangent domains, then I would get another answer every time. And same thing with 2 pi over 3. If I were to add any 2 pi integer set, I would have the same answer. Meaning if I come up here and add pi over 2 pi over 1, which would be 6 pi over 1. 7 pi over 3 would also be the same thing as this. And so that's giving you the infinite answers. So this one right here is very similar, you know, at 2 pi over 3 and then 4 pi over 3, there's no connection. But when we do the last one, it's kind of interesting because there is a connection. We'll take a look at that one in just 1 second. And that's when you really have to start, you know, when you're taking a multiple choice test or something, you have to be careful about these kind of answers. I mean, what I'm really asking you is, so I start at 45, how far apart is all of these? If all of these are 45, aren't all of these 90? So this one can actually be summed up, okay, by just saying, if I start at 45 degrees and add any integer of 90 degrees, then I would actually get all of the rest of them. I mean, just think about it. What is 45 plus 90? It's 135. What's 135 plus 90? It's 225. What's 225 plus 90 is 315. Now, these all work in reverse as well. So we're adding this, but remember, coterminals also have a minus. So technically, there's a plus or a minus, because if I were to go backwards, if I were to go 45 and go in the opposite direction, negative 90 from there, I'd have negative 45, which is what you see there. So these are not very difficult. They just are connecting the world of coterminal angles to the answers you find on the unit circle. All right, so the last thing we have to do is look at what happens when we have a problem that has factoring in it. And why don't I change this one? Sometimes we kind of just did one just like that, but why don't we take a look at one that's already factored? So imagine I had something like cosine of x plus 1 and then times sine of x minus 1, but I'll put a little 2 right here so that we get something different. Okay, and students, for some reason, they have trouble understanding that I've already factored this problem for them. So when they take a look at it, what happens is they kind of get frozen. And they're like, Mr. King, I just don't know what to do. Imagine someone gave you a problem in Algebra 2 that said x plus 1. And here they had 2x minus 1 equals 0. What would you do? You would use the zero product property and you would solve this for 0. And then you would solve this for 0. Right? So this would be negative 1. This would be a half. That's exactly what you're going to do here. But instead of having going straight to the x, you have to first solve for cosine and sine. It's not very difficult. We always have to keep in mind that trigonometry is Algebra 2 with the unit circle. If I were to sum up what trigonometry is in high school, that's what it is. So if I were to subtract 1 here, I would get cosine of x is equal to negative 1. And then if I inverse cosine this, okay, what happens is I just say, where's cosine equal to negative 1? Eventually, you're going to get good enough to just know the answer to that is pi. Right now, you're probably going to have to draw a circle and label it, right? And that's why I got that answer right there. All right, to do this one, I'm going to add 1. You're just reversing Gelndos twice here. And then here we have 2 sine x is equal to 1, and then we divide by 2. And now we're looking for all the values of sine that are equal to positive 1/2. So maybe pause the video and see if you can do that part. I feel like that's the only part that's confusing. Okay, so figure it out in the first quadrant, and then let's expand it. So go ahead and pause that video and see if you can find it in the first quadrant. Okay, so welcome back. I hope you did pause it to be able to figure that out. And so where is sine equal to 1/2? The answer is at pi over 6 right here, right? Because that's root 3 over 2 1/2. All right, so where else is it? Well, then it comes back to all students take calculus. Okay. I forgot my S in that little mnemonic device. Let me fix that. So all students take calculus. And the other place where this would be true would be in the world of the second quadrant. So that would be over here. And if this is, remember this one was pi over 6, so this would be 6 over 6. So this is 1 less 5 pi over 6. So the answer to this question is our first place here at pi over 6, and my second one is there. So x would equal pi over 6, and then the one over here is 5 pi over 6. Now, when you write these answers, because notice we have 3 answers now, you have to write them in order. So remember how we used curly brackets in Algebra 2? You would put these answers also in order. Pi over 6, then pi, and then 5 pi over 6. Okay, so then the only other thing we have to do is just some factoring that you have to factor yourself. So let's talk about what we see here. The solving part, I think we hopefully understand. I will go through it. I want to focus on the factoring part. Imagine that this problem, instead of being cosine squared x minus cosine x, let's just take a second and imagine I gave you c squared minus c equals 0. How would you do that problem in Algebra 2? You would say, okay, Mr. King, I have two c's. I have a common c in both these c's. So if I pull the c out, I would get c minus 1 equals 0. And then if I set those equal to 0, I would get my two answers. That is exactly how you do trig, right? It's exactly the same thing. The difference is that c means cosine, right? So when you come back and look at what I did, I factored out the cosine. Effectively, I divided by cosine and cosine, giving me cosine minus 1. If you need to, use letters and just at this step right here, write down, oh, this means cosine x equals, right? And this means cosine x minus 1. A lot of students have success by getting rid of the whole word and just use the letter. Then you use the zero product property by drawing a line, right here, and setting them equal to 0 and finding your answers on the unit circle. Notice this one has two of them, right? 0, and then also at 3 pi over 2 right here. And then the next one right here, cosine minus 1, I set it equal to 1, and then I solve it, and then I have this like, what the heck? I'm not using 2 pi. It says, right, that the answer is at 0 and then background at 2 pi. Notice how sneaky this is, and this does come up. Look, there's no equal sign. So sometimes they exclude the domain, like on the SAT or something, just to make sure you're paying attention. So if I put these in order, the first one that was correct was 0, and then pi over 2, and then 3 pi over 2. Okay, and then we come back to 2 pi, but it was excluded just because they did it in the directions. And now that I look at my directions, these answers are all right, but they wanted them in degrees. So why don't we put them in degrees? This one would be 30 degrees, and then 180 degrees, and then 5 pi over 6 would be 30 degrees past 180 or 210 degrees. It's funny that I saw that after I did that one, that the directions on this one say to do it in degrees. Not that we did it wrong by doing pi's, but you have to make sure that you answered the right one. Notice this one says degrees. So let's focus on the factoring. We'll get to how I got all these answers in a minute. So let's go back and look at what that would look like. Okay, so sine squared plus 2 sine equals 3. Imagine, right, that I didn't give you that problem. Imagine that instead I gave you s squared minus, make sure I get it right, plus 2s equals 3. How would we solve this quadratic equation? Well, we would set it equal to 0. Nothing is changing from Algebra 2. This is just Algebra 2 right now. And then we factor this very easy problem by looking at the factors of 3, which are 1 times 3. It's a minus, so we have to subtract them. So that would be s plus 3, and then s plus 1. And then we would use the zero product property and set these equal to 0. Well, now just imagine that that's a sine. So you would write sine x plus 3, and then sine x plus 1 equals 0. That's exactly what we're going to do here. So I factored this out. Again, I just made this sine squared plus 2 sine minus 3, and I used s's instead. Okay, and then I factored that out just like you saw. I'm using the zero product property. Here I'm going to solve this by adding 1 and then looking at the unit circle. I already have it over here, so sine this one only here, right? Because that's cosine sine, so I have only 90 degrees. And this one is weird, right? Like, what's going on here? Can sine ever equal -3? Well, if you think about the domain of sine, the range of sine looks like this, right? And where are those mins and maxes? Well, they're at -1 to 1. Like that's the range of sine. So if I inverse this and do inverse sine, it is impossible for sine to be -3. It can only ever be -1. So this part has no solution, making this the only answer. All right, let's do those infinitely. All right, so let me ask you a question. When you look at this answer here, and maybe it's easier to see these infinite answers in degrees. Is there any connection between 30, 180, and 210? The answer is there isn't. So when we did that, we would just have to add, you have to just keep adding 360 pi. This is the answer to the old one. If you go back at the beginning of the video, I changed it. Ironically, some of the answers are the same. It's kind of ironic. So all of these answers have no connection to the next one. 30 plus 360 degrees z, meaning every integer of that. And then 180 degrees, I'd have to come back 360 degrees from that to get it again. And then the last one, same thing, I'd have 210 degrees plus 360 degrees z, meaning every integer. And don't forget, it's actually plus or minus because you could go in the opposite direction. So when I look at these two, there is a connection between these two, right? Because if I look at this, I just want you to look at the cosine values. Aren't they 0 here and here? And then what's that line represent? Well, it represents 180 degrees or pi. So I could just say that these two answers are actually the same answer. If I take pi over 2 and add any integer pi, then let me just say what I mean. If I take pi over 2 and I add pi, wouldn't that be 2 over 2, which would be pi over 2? And so that's what that's saying. Don't forget, it's also minus. And then the 0 one is interesting because it would be 0 plus 2 pi z. But we don't usually include, like, if you gave me an answer that's 0 plus 1, I would look at you like you're crazy. That's 1. So if you did 0 plus 2 pi over z, that's weird. Mathematically, we don't break down the 0 plus part. All right, here, the only answer is 90. So it's 90 plus 360 degrees z. Please listen to me very carefully. The solving aspect of this is very easy. Some people might have a little trouble with doing factoring. The strategy there is to just change it to one letter rather than the whole function. But it really comes down to, do you know your unit circle? And if you don't know your unit circle, do you at least know quadrant 1? Like, do you know that pi over 6 will generate certain values for sine and cosine? If you don't know that, I'm going to just warn you again, you're in a lot of trouble in trigonometry. So maybe go back and watch the video on the unit circle. The solving aspect, again, not too bad. Well, I hope you enjoyed this video. I hope it made sense tying the solving practices of Algebra 2 to trigonometry.